Today, we're diving into a company with a pretty huge ambition: to build the engineers who will build the future. But, to really get their vision, we first have to tackle this strange paradox that's sitting right at the heart of the whole AI boom.
Okay, so this feels like a total contradiction, right? I mean, all we ever hear about is this crazy, insatiable demand for AI skills. So, how on earth could an AI boom actually lead to an unemployment crisis? It just doesn't seem to add up, and that's exactly the paradox we're going to unpack today.
And this slide really lays out the problem perfectly. Over on the left, you see what we all know. Global demand for AI talent is just exploding. We're talking a projected $2 trillion market. But then you look to the right, at the talent supply in a huge market like India, and it's like a leaky funnel. Let's take a much closer look at that leak. Yeah, so this isn't just the small gap we're talking about. The source material calls it an employability crisis. And honestly, when you see the numbers, you'll get why.
44%. Just let that number sink in for a second. It's so stark, and it really represents a massive failure somewhere in the system. But 44% of what exactly?
So here's what that number actually means. You've got literally millions of STEM students graduating, but more than half of them are left without a job. The system is cranking out graduates, sure, but it's not producing employable graduates. And that's the real problem here. So, what is going wrong?
Well, the source material points right at this as the root cause. A staggering 80% of colleges that are supposed to be teaching this stuff just don't have a practical, up-to-date curriculum or even the right faculty to teach it. It's kind of like they're teaching the history of baseball instead of how to actually hit a curveball.
And this timeline just shows how fast the ground is shifting under everyone's feet. Back in 2010, it was all about mass hiring for basic coding skills. But by 2030, companies are going to want AI-native engineers, people who can build whole autonomous systems. The goalposts haven't just moved, they're in a completely different stadium now.
And this quote just hits the nail on the head. The real threat isn't that AI is coming for engineers' jobs, it's that AI is coming for the jobs of engineers who don't get AI. Being just average is simply not a good career strategy anymore. So if the old school education system is failing, what's the alternative?
And this brings us right to the proposed solution. Now, the idea here is to be way more than just another online course or a coding bootcamp. It's about completely rethinking the goal of education itself.
And here it is, their core philosophy. I love the active language here. They engineer employability. So the claim is, they're not just throwing content at you. They're actually building a whole system that's designed from the ground up to produce one specific outcome, a job-ready engineer.
This comparison really spells out the argument. On one side, you've got the traditional models, which they describe as either totally passive or just way too expensive and inaccessible. And on the other side, you have this new model, which they call outcome infrastructure. See the shift? It's all about moving the focus from just learning to actually doing. So how does this so-called engine really work? All right, let's pop the hood and see exactly how this employability engine is supposed to function.
So this diagram shows the whole process. And you'll notice it's not a straight line. It's a continuous loop. Learn, build, and evaluate. But the really critical step here seems to be that personalized intervention, where they pinpoint weak spots and help you fix them before the whole cycle starts over again. It's designed to be an adaptive process, not just a static, one-and-done course.
Okay, so the whole engine is built on these 4 pillars. First, it starts with a really structured curriculum, but it very quickly moves into project-based learning. We're talking students tackling over 100 real-world projects. Then that's all supported by a hybrid model, which combines the massive scale of online learning with the accountability of having actual offline support in college labs. And finally, there's a whole engagement system designed to fight against those high dropout rates that you see in so many online programs.
So the whole point of this entire process is a complete transformation. It's about taking a theory-only learner and turning them into a state-of-the-art builder. The idea is to teach students how to think like a tech lead, someone who can actually build products from scratch, not just someone who can pass an exam.
All right, now this is a pretty bold claim, you have to admit. What we're looking at here is a comparison between a student from your average college and one from a top-tier elite school. And the argument they're making is, look, you can't really change a person's raw aptitude, but what you can do with this model is completely level the playing field in 4 absolutely crucial areas: the curriculum, real-world experience, faculty quality, and industry access. That's a huge promise.
And the model is designed so that everybody wins. Students pay nothing up front, and they get a shot at a much higher salary. Colleges get to boost their placement stats and open up a whole new revenue stream.
And companies, well, they get access to a steady pipeline of talent that's actually ready to do the job.
So a good model is one thing, but can it scale? I mean, how do you take this from a small group of students to hundreds of thousands? Well, that's where this idea of a flywheel comes into play.
And here's the absolute key to their whole scaling strategy. Instead of trying to sign up students one by one, which would take forever, they partner with entire colleges. And just like that, they get access to thousands of students all at once. They're scaling by institution, not by the individual. It's a game changer.
This slide shows how that growth is supposed to just keep accelerating. It's this self-reinforcing cycle. So more students in colleges means more cool projects, which then attracts more companies, and more companies means better job placements, and those success stories, they attract even more colleges. You can see how each part of this ecosystem just feeds the others, creating its own momentum.
And here is that ambition laid out in plain numbers. The plan is to go from 20 colleges to 400 in just 5 years. That would create this massive ecosystem of over 120,000 active students. I mean, this isn't just growth. This is a plan for total market dominance.
So let's zoom out. What are the bigger implications here? Because if a model like this can actually work at that kind of scale, its impact could be felt far beyond just one company or even one country. And that leads to their ultimate vision, which is to become a core piece of infrastructure for the entire AI economy. Think about it. Just like GitHub is the fundamental infrastructure for how developers collaborate on code, the goal here is to become the fundamental infrastructure for how we produce and place AI talent.
And this all brings us to one final, really provocative question. For a very long time, the main job of a university was just to provide knowledge. But in a world where practical skills are everything and education costs are just through the roof, is that old model really enough anymore? Could it be that the future of higher education is less about teaching and more about guaranteeing outcomes? It's definitely a question worth thinking about.